Okay, so really quickly, I'm going to talk a little bit about outliers, so we can talk about what that means. An outlier basically is a data point we don't expect to see. Okay. And normally, what does that mean? Normally, it's way too big, too large, or too small. That's what's normally happening. So it's out of the range that we would expect to see. It's not expected, okay? So whenever we start talking about expected values and normal data and stuff like that, this guy just kind of messes us up. And the problem with that is whenever we have an outlier that shows up in our data, outliers tend to skew our data. Skew our data. What does that mean? It means it pulls the data one direction or another. Okay, so remember at the beginning of the semester I was talking about tomatoes and fertilizer and stuff like that, right? If we were going to experiment with tomatoes and fertilizer, and if we were measuring things and we had like 40 grams for one tomato or whatever, and 42 and 43, 43, and then all of a sudden we had 400 grams, okay, and then there was 39 grams and so on and so forth. If we had that one data point in there, okay, we said, well, probably that was a matter of either the person who was writing it down forgot to put their decimal point in there, 40.0, or maybe the person who was typing it in the computer put an extra 0 by accident. So these could be some random errors going on here, right? That's what we said. But what if we really had that one tomato and it really weighed 400 grams? Okay, maybe it's like the world's largest tomato kind of thing going on, or something weird happened to it. Maybe it was not really a tomato. Maybe, I don't know, it was really a cantaloupe or a watermelon or something. Who knows? But if there was something in there, whenever we go to take the mean, median, and mode of this data set, everything's hovering around 40-ish, but this one is 400. If I took the average of just these 5 data points, add them all together and divide by 5, it should be around 40-ish, right? But what happens when I add in that 400 instead of a 40? Well, now I've got, basically what? 400, close to 560 divided by 5. So it's going to be like 100 grams is my mean in this set. So whenever your average is higher than most of your values, there's a problem. This would drag the mean larger than the majority of your data points. Okay, that shouldn't happen. Normally average is what? In the middle of my data points, not larger than most of my data points. So that's called skewing my data. Okay, that's a problem. We don't want that to happen. So real quickly, there's an example, and I actually was at, I think it was University of North Carolina, yeah, where this conference took place. And they were talking about, they were doing some statistics on their geography majors. Okay, that's cool. They wanted to be able to advertise and say, if you're an English major, you're probably going to make this much money. And if you're a math major, when you graduate with your degree, you'll make this much money. This is what our average alumni from, I I don't know, journalism makes and stuff like that, just to be able to advertise so that people would know, oh, if you go into an art major, maybe you can make this much money. So when they did their data, it turns out that basically a graduate assistant was doing the data and plugged all the stuff in. And for some reason, geography majors, their average income was really huge. Okay, now think about that, geography. That's like the study of, you know, the maps and stuff like that, the study of the world, where things are, and mountain ranges and whatever. Geography, a study of the world. Okay, study of the geo, right? Okay, what do people with that major do? I don't know. Maybe they can be archaeologists. Maybe they can work for certain websites or go do certain things for, I don't know, the rainforests or park rangers or something like that. But the point being, I wouldn't expect them to make millions of dollars, and the average was turning out to be millions of dollars. Okay, so that kind of became a problem. And the graduate assistants went to their faculty member and said, we have an issue, I don't know what it is. So as they go through, what they did was they went through all the surveys. And what did they, okay, so how did they get their data, basically? They sent out a survey to all of their alumni for the last, I don't know, say 10 years, and asked them to please fill it out and tell us what your major was and how much money you're making. Okay, seems straightforward, right? Okay, and so they had taken that and they'd split it out by major, and then they went and entered it into this database. Well, as they go and they're looking through, what do they see? They go and they pull out the ones just for geography. What do they see but that they had one particular alumni named Michael Jordan who had submitted his survey like a good alumni does, went through and said, oh, you want this information from me? Fine, I'll give it to you. And because he appreciated his school that he graduated from so much. And he sent back his survey like a good guy. Okay. The problem is, who's Michael Jordan? Yeah, great basketball player, right? Yeah, and he may have a degree in geography, but he's not using that degree to make his millions, right? What's he using to make his millions? He's using his basketball skills, right? Okay, so while he does have that degree and he does make millions, or did make millions, I guess, that's not what we would expect a typical not the money of a typical geography major, right? Unfortunately. So what happened? You add his millions in with a few 50,000, 70,000 people, and all of a sudden the entire average of the data goes way up, right? He's dragging the mean up by just this one data point, okay? So he is clearly an outlier. He's not expected value. In fact, he is going to mess up our statistics as we look at him because he is dragging things so much. So that's kind of the idea of an outlier. All right, so as we were talking about Hank Aaron and Babe Ruth before, I know there's a lot of stats in sports. As we were talking about them, one of the things that came up was, you know, Babe Ruth, he had that 60, but maybe that was an outlier. Maybe it was a fluke. Maybe it just happened and it's not an expected value, right? So maybe that messes up his average number of home runs. Or maybe the 0 was really low for him, you know, maybe that's pulling him down. Maybe that's an outlier. So if we could kind of start figuring out what makes something an outlier, that might be helpful. Okay, so one of the basic ways that we look for outliers in statistics is that we do a box and whiskers plot. Want to find out if there are outliers? Now, there's lots of ways, and by the time we're finished with this course, there will actually be like 3 or 4 methods, and you'll be able to do them all. But the basic one that I'm going to show right here is use a box and whiskers plot. Okay, so once you have your box and whiskers plot, which we already have for both Babe Ruth and Hank Aaron, because we did it before. Here's Babe Ruth. Once you have that, then what we're going to do is we're going to figure out a few key things, and once we have that, we'll move on. So we're going to, instead of having to have this big, huge thing going right here, which we've got it, and we know how to make that box and whiskers plot now, I'm going to go back to what I called before the 5-number summary. For a set of data. Okay, 5-number summary. And if you have these 5 numbers, you can kind of figure out what's going on. So there was the minimum, I can't spell today. There was the maximum. So you had your 2 ends. Now think about it. If I have the minimum and I have the maximum, then I can figure out the range, right? Okay, so those are important to know. We had the median. Remember, the median tells me 50% of the data is above this point, 50% of the data is below this point. And we had Q1 and Q3. And if you remember, this is the lower quartile, which tells me 25% is below this. This is the median, Q2, which tells me 50% is below that, and this is Q3, which tells me 75% is below that. And actually, if you really want to get technical, remember that Q4 is the maximum, and all of your data is below that. So this would be like Q0 if you wanted to continue that thought process. Okay, so for Babe Ruth, let's look at his box and whiskers. His minimum was 0. His maximum was 60. Right? His median, we hit it right here, that was 38. Right? Okay. And then his Q1 was way down here, it was an 11. And his Q3 was way up here, it was a 47. Okay, so this would be Babe Ruth's 5-number summary when we're talking about his home runs, right? Okay, and you can do something similar to that with Hank Aaron if you want to, just so that you can have it and play with it. Just a second, sorry. Yeah. Okay. So you can figure out the 5-number summary for Hank Aaron. Hopefully you did that real fast. I've got a 10 for the min, a 47 for the max. The median was a 34. Q1 was 25. Q3 was 44. So hopefully you found that real quickly. Okay. So if I want to know if something's an outlier, then here's what I do. First step, finding an outlier using the box and whiskers plot. Step 1. Find the IQR. What the heck's an IQR? This is the inner quartile range. Okay. Also, you could think it's the range on the box. Okay. So in other words, whenever you're looking at the box for Babe Ruth, let me make sure we know that this is Babe Ruth. Sorry, you can do Hank Aaron on your own. Okay, whenever I'm looking at the box for Babe Ruth, the range on the box is from the top of the box to the bottom of the box, or the Q3 down to the Q1. So I've got, it was 47 and 11, right? So the range for this box, to find that total distance, I would do what? The top guy on the box, not the whiskers, we're just wanting the box. The top guy on the box, which is Q3, minus, finding range, total distance, right? Q1, which is the bottom point on the box. So it would be Q3 minus Q1. Well, that's a pretty easy calculation to make, right? It's just a subtraction. For Babe Ruth, his IQR, let me stick that over here. IQR for Babe Ruth, 47 minus 11, right? Because his Q3 is 47, his Q1 is 11. Well, that looks to me like 36. Is that okay? All right. So find his IQR. Done. We did that. Step 2. Find 1.5 times the IQR. Okay. Now, that's just a multiplication again. So real quickly, let me tell you what that means. Whenever we're looking statistically, what we say is that if we have a normal value for, in this case, Babe Ruth's home runs, we would expect it to be within 1.5 times of the IQR above the box or below the box. Okay, so basically what we're about to establish is a new range, and we're going to say inside of this new range, any value that's inside of that, we're just going to call it normal. Okay, so let's do this calculation. Well, 1.5 times 36 was the IQR for Babe Ruth, right? Well, half of that is 18. 36 plus 18. Help me with that arithmetic. I think I have it somewhere. I don't know why I don't have it written down. I do have it written down somewhere, but yeah. That's not it. Stinker. Here we go. Yeah, half of that is 18, so 54. There we go. Dang it. Okay. So, this will give the number to add or subtract from Q1 and Q3. Okay, so here's what we're saying. Anything that falls inside of the box, we're good. Those are expected values, no problem, because they're in the middle 50% of our data, right? No issue. It's the ones that might be way out here on the whiskers that might be too big on this end or too small down here on this end. So what we're going to say is from Q3, right here, we're going to add and figure out some value in a new range, okay? And this range will be my range for normal values, okay? If we're inside of that range, if all my data points are inside of there, then they are considered normal, okay? So because Q3 is at the top and I want to go this way on the whisker, I'll add. But Q1's on the bottom and I want to go down here to see if any of these data points are smaller or are too small, right? So from Q1, I'm going to subtract, okay? So we got to do a little bit of arithmetic. Again, it's not terrible arithmetic, but it's a little bit of arithmetic. And I'm going to show it right here. Step 3 is Q3 plus whatever that value is, 1.5 times the IQR. And Q1 minus whatever that value is, 1.5 times the IQR. Okay. So again, we're going to just do this arithmetic and see what happens there. Okay, so Q3 for Babe Ruth was 47 plus 54. Okay, 47 plus 54. Well, 47 plus 54, I don't know exactly what that is, but I know it's bigger than 60, right? So let's find out exactly what it is. Let's see, it's an 11, carry the 1. Is that 101? Double check my arithmetic. Yep, that's what I've got. Yeah, 101. Okay, so this is the top, and they call it a fence. Okay, for normal values. Okay. And then the other one is Q1, which for Babe Ruth was 11, minus the IQR times 1.5 is 54. Okay, and again, I don't know what that is, but that's a negative number, right? And it definitely is that negative 33, 43, 43. So it's definitely too small because home runs, number of home runs has to be positive, right? So that's the bottom fence for normal values. Okay. So let me do just a real quick mock-up of what this is going to look like. Okay, so in here I have Babe Ruth. He's got a 0 here, he's got a 60 here, and somewhere in the middle he's got a box that looks something like this. Right? Here was his Q1. He was actually spread out, so I'm going to do like this. Here was his median, and here was his Q3. This is an 11. This is a 38, this is a 47, this was his minimum, this was his maximum. So that's what his box and whiskers looked like before, right? But now what we're saying is we're going to add to this guy the 54, and we get to 101 up here, and that's the top fence. Okay? And what we say is if he has any data points that are bigger than 101, then they are outliers. Well, we already know that his largest data point was here at 60, right? So he doesn't. So even though 60 seems unusual, it is not an outlier, so we don't get rid of it. Okay, so that's the point, and you can't just dump a data value because you think it looks wrong. Okay, you have to check. You have to do the math, and you have to find out for sure. Okay, and then here on the bottom half, I've got my Q1. I do Q1 minus 54, right? This was Q3 plus 54. This is Q1 minus 54. And when I subtracted it, I got way down here. It was negative 43, I think, was the number. Okay, and this was my bottom fence. Right? Well, does he have any data points that are less than negative, whatever that was, 43, I think it was? No, he can't possibly have negative number of home runs, right? And so he can't possibly do that. Can't possibly have less than a negative 43. So he doesn't have less than that either. So Babe Ruth doesn't have any outliers. No outliers for Babe Ruth. Even though some people think, oh, that 60 was a fluke. Okay. So what I'd like for you to do on your own time, just for funsies, making sure you understand all this and you can do it on your own, is you need to go through and make sure that you can do this also for Hank Aaron's numbers, right? So Hank Aaron's 5-number summary. In case you don't remember. Was his min was 10, his max was 47, his Q, I'm sorry, let me throw his median in there, was 34, his Q1 was 25, that's what I've got, yep, 25, and his Q3 was 44, okay. So there's his 5-number summary. You can go through and play with his stuff and find his, do the steps that I just wrote for you, right? Find his IQR. Find his IQR. Find 1.5 times the IQR. Whatever that number is, add it to Q3. Subtract it from Q1. Find your fence numbers. That's step 4. Find fence numbers and check against your max and min. Okay, if the max and the min, if all of the data points are inside of those fences, the top fence and the bottom fence, then you got nothing to worry about. Okay, no outliers. But if you have a maximum value or even 2 or 3 data points that are above the top fence or a point or 2 that are below the bottom fence, now you've got outliers. Okay, so find his IQR, 1.5 times the IQR, Q3 plus 1.5 times the IQR, Q1 minus 1.5 times the IQR, and then check against max and min. So basically what ends up happening, those are your steps, don't forget them. That's what you're doing on your own. Okay, so basically what ends up happening here is I don't actually need the box and whiskers plot, right? I can recreate the box and whiskers plot if I just have that 5-number summary. So sometimes you'll see data and they'll be talking about something, but instead of like, here's the data boxes, here's the box and whiskers, here's this, here's that, they'll just kind of sort of say, oh, here's your, here's your 5-number summary, so check it against, check it against the data, find the IQR, find the 1.5 times that, and go from there, and you're just expected to know how to do it, okay? So that's the idea behind finding outliers with a box and whiskers plot. I think that, you'll have homework on that, and hopefully you'll be able to use it. There could be some data sets that do actually have outliers, so don't go thinking that just because we didn't get any outliers that you never get outliers. That's not true. Right. That's the basic idea behind the outliers, and I'm going to call that the end of this video. Yay, short and sweet. Have a great week. Let me know if you have questions, and just remember, what's an outlier? It's something that falls outside of the expected values. All right, thanks.